Hey, and welcome to SanfordFlipMath. We are again working in PreCalculus. We're working on section 2.5, which is about complex numbers, and some of the stuff we're working on here, we are following along with the PreCalculus book, Functions and Graphs by Demana, Foley, Kennedy, and thank you to them for putting together a decent book. The focus in this section, as is implied by the title of the section, is about complex numbers. And so we need to talk a little bit about I. And so just a quick reminder. The idea here is that, if I have an equation x squared equals 4, I know that there are two values that make this equation true. X equals 2 or x equals negative 2. 2 squared is 4. Negative 2 squared is still 4. Okay. The problem is when I have an equation such as this, where x squared equals negative 4, and so as you are aware, when you square a number, whether it was positive or negative, you don't get a negative. And so the problem here is, how in the world can that happen? Well, it actually turns out that it's useful in some physics applications to keep track of where this happens. Usually it is in electronics kind of things. It has to do with like phase shift between current and capacitance, and or how capacitance affects current and voltage, something like that. But there's a relationship there. So basically what we need is a tool to keep track of the square root of a negative. Okay, so now technically what's going to happen here is when you take the square root of both sides, as we've talked about, the square root of x squared is absolute value of x. And so this is going to be equal to the square root of negative 4. So here's your positive and negative. And the problem is that, again, how do you deal with taking the square root of a negative? Well, basically, what we're going to do is revisit the idea that we have this bookkeeping tool where it's just I. It's really, there's not a real number that you can square and get a negative, but the idea here is we have an imaginary number. Stuff really happens with this. It's not like we're just making stuff up, but this imaginary number that would make this equation work. Okay, so just so we're clear, I is the square root of negative 1. Now, a lot of times people talk about I being negative 1, and that is not true. It's the square root of negative 1. And again, there is no square root of negative 1. So again, all this is a bookkeeping tool. It is a way we give it a symbol so we can keep track of it. So if we then go back to this problem, well, the square root of, I can treat this as the square root of 4 times the square root of negative 1. The square root of 4 is 2, and the square root of negative 1, that's I. Okay, now you don't necessarily need to write it like that, but just so you're aware that that's how we're going to handle it. So pretty much how we're going to think about it in our brains is whenever you have the square root of a negative, it's going to end up having an I. Okay? Along with that are what are called complex numbers. Well, a complex number is any number that is a combination of a real number plus an imaginary number. Typically, those get written in this form. This is standard form for a complex number. So a number like 3 plus 2i is a complex number. Negative 2 minus 7i is a complex number. 0 minus 7i is a complex number, but normally people would just write that negative 7i. Similarly, 5 plus 0i would just be 5. So please note that even though this is a real number, it is also a complex number. So that means that any number that is a real number is also a complex number. And any number that is imaginary is also a complex number. And then there are numbers within those that are both. Okay, so the little Venn diagram action here. And then within the real numbers there are like irrational numbers and rational numbers. And inside of rational, numbers. There are also integers and whole numbers and even natural numbers or counting numbers. So this Venn diagram gets a little busy, and these are not supposed to touch here. That's supposed to there, and that's supposed to go there. Okay. All right. So lots of stuff going on here. So one other thing here. So this would be called the real part, and this part would be called the imaginary part. Okay. So the real part is the A, and the BI would be the imaginary part. Okay. So nothing real earth-shattering here, and I know you've seen this kind of thing before, but you just need to be aware of it. Okay. All right, well, we're going to do a little bit of arithmetic and simplifying here. And so here's the short version. We're going to treat I like a variable. In other words, we're going to combine like terms and things like that. And the only other issue is that if at the end of it you have a power of I, it needs to be simplified more. If you have a power I, you need to simplify. Woohoo! That was a really good one, wasn't it? All right. So as I'm looking at this, I see 2, I see 1. I can add those. That's 3. I see I and plus 8I is 9I, and yep, that's it. This one, you have to subtract the whole quantity here. So for some people, it's going to make this a little easier if we actually, in effect, distribute that negative. Okay, so now 2 minus 8I, I'm sorry, rewind. Well, you don't need to rewind, I need to rewind. 2 minus 1 is 1. I minus 8I is negative 7I. So this is in A plus BI form. That's the form it needs to be in. Okay. All right, looking at the next one. Well, I have a binomial times a binomial, so I need to distribute everything, or some people use FOIL. So first times first, this is 16I. Outer, 2 times 1. Inner, 8I squared. And last times last will be I. And as I mentioned a second ago, powers of I need to simplify. Well, if I is equal to the square root of negative 1, then I squared ought to be equal to the square root of negative 1 squared. Well, squaring that square root, I squared equals just negative 1. Okay, we'll need that fact in just a minute, so that's worth making a big stink about. Okay, you need to see that. That's going to be useful. Okay, well, if that's true, then that I squared is negative 1. So this is really 16I plus 2 plus a negative 8 plus I, or you can treat it as a minus 8 if you'd like. I'm supposed to do the real part first, and then the imaginary part. Okay, so all I'm doing is focusing in on the imaginary parts separate from the real parts. Okay, that's all I'm doing. Okay, all right. Now the next one that we're going to look at is a little bit more involved, and part of the question is, why is this even in this? Why is this an issue? Okay, so dividing complex numbers, I actually have two problems here. This is not A plus BI form, so that's a problem. Okay. The other issue that goes along with that is that I is in the denominator. Now remember, I, it's funny to say I is. Remember that I is a square root, and you're not really supposed to leave square roots in the denominator. So to rationalize that, what we have to do is multiply by something that gets the square root out of the bottom. Now, I personally prefer this in the A plus BI form, so I'm going to switch this 8I plus 1 around. So 1 plus 8I. It's just, that's the order I like it in. And I could have done that all along. It's just sometimes problems aren't in A plus BI form initially. Okay. All right, so if I multiply the top and bottom by just I, then I end up with an I plus 8I squared. Well, 8I squared would be A times negative 1. That's cool, but I still end up with an I in the bottom, so that really really doesn't help me, so I really don't want to do that. If I multiply by 1 plus 8i, I could do that on the top and bottom. But the problem here is when I do the outer and the inner, I end up with 16i. So I'm still right back to the problem where I have an I in the denominator. Okay, so the way to get rid of it, and you may recall this from previous years, is we're going to use what is called the conjugate. Looks exactly like the word conjugate, which has to do with verbs in languages in English or in Spanish or in whatever. But this is conjugate, which is a noun. Aren't you impressed that I knew that that was a noun? It is not a verb that you are conjugating. Okay, so on the bottom, and I want to do the bottom first because that's the part that needs to work. Okay, so on the bottom, I end up with 1 times 1. Outer would be negative 8i. Inner would be positive 8i. And then last would be minus 64i squared. Now, again, I just want to continue on the bottom for a minute here, and then we'll come back and do the top. Okay? So on the bottom, this becomes, whoop, look at that, that's gone. Well, the only other I that you see here is an I squared, but remember I squared is really negative 1. So this denominator becomes 1 minus a negative 64, because 64 times negative 1 is negative 64. So this is really 1 plus 64, so in other words 65. All right, so my denominator now doesn't have any i's in it. Okay, in the numerator, I still need to distribute. Okay, so I have 2 times 1 is 2, outer is going to be negative 16i, inner is going to be I, and then it's going to be minus 8i squared. Okay, so this is really 2 minus 15i, and just a reminder that that I squared is negative 1, so this becomes minus a negative 8, or in other words plus 8. 2 plus 8 is 10, minus 15i. Okay, now the only other thing that we need to worry about here, and not that I'm worried, is that this is still not in a plus bi form. Both 10 and negative 15i are being divided by 65, so what I'm going to do is break this up. So this is now 10 over 65 minus 15 over 65i, and I got one more thing I can do, and that's reduce that. There's a factor of 5 in both of these, so this becomes 2 over, I believe that's 13, minus 3 over 13i. This is a plus bi form. This is the final answer for that. Well, come on now, work for me. There it is. Okay. Sorry. All right, I'm not going to do the other problem that you see here because I'm worried about time, but I'm just going to point out to you that remember that numerator is 2 plus I times 2 plus I, and that's over 1 plus 8i. So two things need to happen with this. This needs to get multiplied out, and then this thing, to get rid of that, you're going to have to multiply by the conjugate, just like we just did. So this is going to be 1 minus 8i on the top and the bottom. And so you got a lot of multiplying, a lot of distributing, combining, things like that to do with that. Okay? All right, moving on. All right, powers of I. Well, we already talked about how I really means the square root of negative 1, and we're just going to write that like I to the 1. Okay, it's just I. Okay, so I to the 1 is I. I'm going to switch that around. Okay, so I to the 1 is I squared, we again have talked about squaring this, and so now I squared is really just negative 1. Well, I to the third would be the same thing as I squared times I. So this is negative 1 times I, so I'm going to write that as negative I. I to the fourth would be I squared times I squared. Well, that's negative 1 times negative 1, so that's just 1. Well, I to the fifth. Well, that would be I to the fourth times I. Now, that's not the only way to split it up. I just think it's the most efficient way. Well, I to the fourth is 1 times I is I. So I to the fifth is I. Well, I to the 6th, also I to the 4th times I squared. We know I to the 4th is 1. I squared is -1, so that's -1. I to the 7th, I to the 4th times I to the 3rd, equals, well, this is 1 times -I, and again, I'm just taking that -I from here, so -I. I to the 8th, well, that would be I to the 4th times I to the 4th. That's 1 times 1 is 1. I to the 9th, yeah, I know you're saying to yourself, really? You're going to keep going? Well, that's I to the 4th times, whoop, not 4, sorry, I got 4 on the brain, times I to the 4th times I. Well, that's 1 times 1 times I. I to the 10th, you guessed it, tap, 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 tap. I to the 11th, same song, yet another verse. Okay, one more of these. I to the 12th is I to the 4th times I to the 4th times I to the 4th is, you guess it, 1 times 1 times 1 is 1. Alright, so some of you have seen this probably 2 or 3 times. Okay, so I need you to see this. Alright, so I'm just drawing your attention, pardon the pun. Sorry. Now, and we need to make a little conjecture out of this, and this conjecture needs to go a certain way. What some people like to do is say, hey look, I to the 3rd is -I, so multiples of 3 must be -I. Well, please note that this power is a multiple of 3, and this answer is not -I. Okay, so that ain't it. Got all my grammar freaking out now, I know. Okay, so what I do need you to see is that every 4, it starts repeating. So this is all about 4s. So I to the 1 is I to the, every time you get to I to the 4th though, it's 1. I to the 2 times 4 is 1. I to the 3 times 4 is 1. So I to the 16th ought to be, I to the 20th ought to be, I to the 100th ought to be, I to the 152nd power ought to be, yes, that's divisible by 4. Okay, so that also means that if I need to do I to the 19th, well, I to the 16th would be 1, I to the 17th, 18th, 19th, well, so that's 1, this would be -1, -I, I'm sorry, -1, yep, -I, oh, I missed something here. Oop, yep, I did. Sorry. So 17th would be like I to the 1, so that's I. 18th would be -1, and 19th would be the -I. So this is that pattern. Okay, so you have to decide how you're going to handle this, but memorizing this would be awesome. Now, again, you don't have to memorize this. What you can do is do what I just did. You really absolutely need to know that I to the 1 is I, or the square root of -1. You really have to know that I squared is -1. But after that, you can do any of this. Okay, so what about I to the 537th power? Well, I happen to know that if you know that the last 2 digits were divisible by 4, okay, so if I do 536, I know that 36 is divisible by 4. So 536 is also divisible by 4. So this is one more than that. Well, I to the 536 would be 1 times another I, so this is just I. I to the 5003. Well, I know that 5004 would be a multiple of 4. So you can decide how to do this, but so I to the 5,000th would be a multiple of 4 times I to the third. Well, this is 1. This is negative I. Okay, so here's the short version. Find the nearest multiple of 4 and count from there. Any I to a multiple of 4 is going to be 1. Okay? All right, one more example and then we're out of here. Okay? Question really is, when do we actually use this? Well, this is probably the most common way to use this. And basically, you start out with what looks like a fairly normal quadratic equation. Okay, so I'm going to put it in standard form. So I'm going to subtract 5x from both sides. And while I'm here, I'm going to add 8. And I know some of you will want to separate that into 2 steps, and that's fine. This is not going to factor. Factors of 19 that add up to negative 4, yeah, that's just not going to happen. Okay, so I'm going to do quadratic formula. So the opposite of negative 4 plus the square root of negative 4 squared minus 4 times a times c. 4 plus or minus, this is 16 minus, well, 4 times 19, 4 times 20 would be 80, so this is 76 divided by 2. 4 plus or minus the square root of negative 60 over 2. Okay, I'm going to run out of room soon, but I'll flip to the other side if I need to. All right, so 4 plus or minus. Now, 60 is 2 times 30, 2 times 15, 3 times 5. Here's a pair of 2's. The square root of 4, the square root of 2 times 2 is 2. I'm going to leave the 15 in, and then just a quick little reminder that the square root of the negative part is I. Okay, so we'll just kind of draw attention to that. This is over 2. Now, every one of these terms now has a 2 on the outside, so I can divide all 3 of these by 2. So this becomes 2 plus or minus I square root of 15. This is a plus bi form. Now, some would argue that this looks more like a plus ib. So if you want, you are welcome to do this. Just please, 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 please make sure it's really clear that the I is not in the square root. Okay? The I cannot be in the square root. So here, the short version of this one is basically solve it like you already do, and it's just when you come up with the square root of a negative, just remember the square root of the negative is represented with I. Okay, well, thank you much. This is section 2.5, again, for pre-calculus, and thanks for tuning in. Bye-bye.